Students, can someone tell me what we studied in the previous class?
So we studied state reduction and
Yes, state reduction we had studied, right? And I hope you guys have extensively understood regarding the same, right? Is it all clear with the concepts that we discussed so far?
Yes, sir.
Yeah, okay. So can someone tell me why is this state reduction needed? Is it really an important step that we are doing?
to reduce the state diagram.
Okay, that is one straight answer to reduce the state diagram. What else is the importance?
So it gives clarity about which state converts to another state. Like especially if we have fewer than equal, then we don't need to separately show them. We can just show one of them and show the conversions from the other state to so and so state.
Okay. And then any other answers that I can have?
And while construction, we can make it more compact.
Yes, good. Yeah, I was expecting for this answer also. We can make it more compact. And due to which, Mamta, what happens? If the construction is compact, what happens? Mamta, yes. Lavanya?
Yes, sir.
Yeah, what happens if the circuit is compact?
It works in a better way. It would be more efficient if it is compact.
In what way? Can you please explain?
Uh, so lesser components would be required, so it wouldn't be that bulky.
Good, good. Okay. Thank you for the answers, all of you. So we are looking at minimizing the structure in such a way that we have less number of states. So ultimately, if I have less number of states, it means it's enabling me to have a simpler circuit. Okay. So once I have a simpler circuit, I would be using less number of components. If I use a less number of components, then the circuit that is needed for implementation also becomes simple. So when the circuit becomes simple, okay, then it's altogether a very easy way to get things manufactured as well. Okay. Okay, so now I think you all have understood the importance of reducing the state. Sometimes what can happen is there can be a question on this, uh, but many times, these kind of complex scenarios wouldn't be asked. But I wanted to discuss this complex situation wherein it helps you analyze different things. Okay, so in fact, this is a complex case here which I've taken, uh, where there's three kind of substitutions happening. First, I try to compare, that is one kind of substitution. Then I make E is equal to G. Then here again I make it G. And again I compare this with here. Okay. So one more state I reduce. So this one after the other kind of comparison that happens, and step by step comparison that happens, and this huge state graph, okay, is actually reduced to a smaller state graph. Okay. So today we will get into another section, okay, which is called your sequence detector. Okay. Can someone tell me what's a sequence? What's the sequence? Just a
An
general.
ordered pulse.
Okay, an ordered pulse. Suppose if the sequence changes, is there any meaning in it? If the sequence changes, is there any meaning in it?
The output changes, sir.
Yes, the output changes. Good. If the output changes, then there's no point in us having a communication, because whatever information that I have passed, if it's not coming across the output, then there's no point at all, isn't it? Right? So this kind of analysis has to be done when you think of passing information from one end to another end. Okay, so which means reliable information is needed whenever you transmit your signals from one point to another. So if the sequence changes, then whatever data is sent is all junk. Okay, because it doesn't make sense. There's no point in having a communication at all. Right? Okay, so I want you to have a look at this. Of course, we have seen this extensively previously as well. Okay, where your state machine, okay, can be implemented with two subcategories. Okay, the one is Mealy and the other one is Murray. So we have seen this, but just for the purpose of revision, okay, just for the purpose of recalling concepts, I have put it across. Okay, so when I say I'm implementing across a Mealy, okay, then the output depends on present state and present input. Please make a note of this, all of you. All of you make a note of this. Whatever I have written here, please make note, and then I would start explaining it.
So can you maximize the screen?
Yeah, I would. Is this better?
Yes, sir.
Alternatively, you can even zoom in your in-app as well. So all this will actually help you in understanding, or it will give you a quick glimpse. Mealy, what should be the representation, and Murray, what should be the representation. So immediately you can go ahead with your state diagrams and with your sequence detectors. So when we look at this screen, okay, when we look at the diagram, we get the information that if it's going to be a Mealy representation, then the output depends on the present state and present input. Now you should be knowing, okay, what is your present input and what is meant by present state. Okay, and how do we represent? Okay, we represent it input by output, and the state. Okay, it's going to be S0. But here in Murray, okay, the output is dependent on present state only. Okay, so that's important. It depends on the present state only. And how do we give the representation? Example S0 by output. Okay, right. So in this diagram, you can understand that there's an input. Let's say, for example, there's a decoder. So you have an input. You have M means memory. Okay, please make note. It's a memory. So input decoder memory. The output of memory is going to be state. Okay, and it is connected to an output decoder. So ultimately, from the decoder, we get the outputs. Right. So the thing that you should understand here is this is my present input. The inputs that is given to a decoder or to any circuit is referred to as present input. What exactly are you giving at the moment? Okay. So if the circuit is able to remember, then it means that it has some memory. Okay. Then the output of this memory is called the state. Okay. So you should be able to recall the initial diagram that we drew, okay, in the start of our module. Do you all remember this diagram? Yes. Can I have some responses? Do
Yes,
you all
sir.
remember this diagram? Yeah.
Yes, sir.
Yeah. So here you have your input logic. So input logic can be, I have shown there as decoder. Okay. It can be anything for that matter, any input, and the inputs that I'm giving here. And consequently, these inputs, okay, will be connected to your output. So which means this is my present state. This is going to be my present state. And as you know, this is my state. The output of memory is always my state, and this is going to be my uh, present input. Okay. So your output is actually influenced by the state of the memory and the present input. So whatever inputs you are giving and the state, which means the output of memory. So if I have these two, then it is called Mealy modeling. It's called Mealy modeling. Suppose I have just only, okay, if I only have my memory state connected to the output logic, but we do not have the input variables, okay, so which means it is not dependent on the present input, it's only dependent on memory. So if it's only dependent on memory, then that kind of structure is called as your Moore. So I have a quick question for you all here. Which model seems to be better, Mealy or Moore?
More, sir.
In what way?
Because it depends only on one factor.
Depends on one factor. Okay. And then, can I have any other answers?
So the extra connection is not needed, like in the case of Mealy's model.
Mm. It's as good as your friend's answer. Any other points? Any other points? See, I cannot say which is better and which is not. Okay. It ultimately depends on what kind of application that you are looking into. Of course, Mealy takes a little longer to process because it has two variables, okay, to be looked into, and Moore seems to be a little faster. But even though it seems to be a little less complex than Mealy, the most used is only Mealy, okay? Because that actually is dependent on the kind of outputs, okay, that it gives through. Just give me a moment. I will show you the differences between Mealy and Moore, okay, so that you guys can understand as to how these are impacting the utilizations. Okay, probably maybe not now, maybe in our, I think next hour, okay, the next lecture, I will be displaying, the differences between Mealy and Moore. So one thing that you should understand, your Mealy has two variables here, okay, which is present input and state, and your Moore has just only the output of memory. Okay. So Mealy 2, Moore 1. And the kind of representations, yes, we all are very much aware. Right? So this is my Moore. Okay, the output comes inside the circle, but here it's only the state and input output is outside. So that is your Mealy. So Mealy is somewhat kind of comfortable with everyone, because here you just immediately get to know what is your input output, and here in the circle it's only the state. Okay, but here it's like state along with the output, and for input you have to look somewhere else, right? So sometimes this creates a kind of confusion between the inputs and outputs. So sometimes a few students tend to put the input here and the output here. Okay, so that shouldn't be the case. Okay, fine. So now that we have understood between Mealy and Moray, so let's go ahead and check as to what is a sequence detector. Fine. So let us take an example here. Okay. What I'll be doing is I have 1010. Okay. So I want to detect this sequence, and I have a stream of data here. Okay. So my stream of data is the whole thing here. Okay. Do not consider the flower bracket. Okay. Do not consider the flower bracket. So just consider this data here. Okay. The whole data here. So in this, I need to recognize my data, which is 1010. So in that case, what I will do is, I will try to check, okay, where I'm getting this 1010. So at this point, I'm getting that sequence 1010. So in that case, my output is going to be 1. Okay. Now here, if you just have a look, I just have 1000. So will this give me an output? Will this sequence give me an output? Students, will this sequence give me an output?
No, sir.
No, it wouldn't, right? It will only recognize that information which I have given there, right? So what is that information? It will only check for 1010. So here I have that 1010. Okay. So if I recognize this pattern, then only my output becomes 1. Okay. So which means it is telling that I have detected this particular sequence. So stream of data can be anything. Okay. So it can be, uh, you know, uh, it can be 8 bit, 16, 32, 64, 128, okay, 512, 1024. So data can be anything. Okay, it can be of any length. But then if I can just figure out this 1010 in that stream of data, then I detect, or I say my output is 1. It is just like this. Okay, all of you are standing in the line. Okay, and then I am just looking for one of your classmates. Okay, so if I find one of the classmates, I will say, please step forward. Okay, so it's just like that. So here I have found this combination of sequence, which is 1010, and then I would say that I have received one pattern of such. Okay, so my output turns out to be 1. Say for example, here we will just change it a little. Instead of 00, so here also let me make it as 1 0 1 0. Okay, so if I have this 1010, here also it will recognize and it will say, yes, I have detected a sequence and my output is what? 1. Understood? Any doubts here, students, up till what concept I have discussed so far?
So can you repeat the last part which you told?
Yeah. Now, if in case the sequence here, okay, say my question is not 10001010, and I just change my question, okay, to 11 and then 1010. So here also I can find one more sequence, isn't it? So once I find this sequence, I will make sure that my output is 1. Okay, it's just like finding something that you need in a big set of data. Okay, there's a big set of data, and you are searching for, or you are looking for a pattern. Okay, say in a big box, okay, there are blocks which are of different colors. So I will tell you to pick up all the green blocks. So what you would do, you would search all the blocks one by one which is in the big box, and then you will try and pick it out. Yes or no? So consider that block as the sequence. Okay. So if I have recognized this sequence in a stream of data, then my output turns out to be 1. Okay. If you find a green block in the big blocks, then what would you do? You would pick it out. Yes or no? Or will you leave it with the other blocks all mixed up? What would you do?
Pick it up.
Yes, you will pick it up and you will keep it aside, isn't it? So the same way here. So we are looking at sequence of data, right? And we are looking at this pattern as to how it is. And once we find the pattern, then my output is obviously going to be 1. Any doubts here till the concepts discussed so far?
No, sir.
Okay. So have you all taken note of this?
No, sir.
Yeah. Just only take note of example, the bit stream data. Okay. And this diagram I will explain you in a while. Okay. Just give me 2 minutes. Till then, you guys can take down the example. If possible, yes, go ahead and take down the diagram as well. I will explain it to you and you can understand it much better. Fine. So now that you know what is a bit stream, okay, so let's get started, and we will try and understand as to how this is done. Okay, I want all of your concentration. Okay, please look into it. Now, since I have 4 bits here, 1, 2, 3, 4, so which means I'm going to have 4 states starting with S0, S0, S1, S2, S3, right? So the number of bits corresponds to the number of states here. Okay. Now, in the first case, okay, every state, or you should understand that every state will have 2 cases, either 1 or 0, right? So what kind of model that I have employed in this diagram? Is it Mealy or Murray? What kind of model is it?
Mealy.
Yes, it's a Mealy model. Okay, because I have input and output across, right? So the number of bits here, okay, corresponds to the number of states. So this point, I think all of you have understood. So here you can actually see the sequence, which is having the number of states corresponding to the number of bits here. Now that point is clear. Now let us take it one by one and we will try and understand. Now S0 moves to S1 if it gets a 1 as the input. Okay, so this one, if it gets, then it will move to the next state, which is S1. Okay, so it moves to the next state, which is S1. Next, it will what I will do is I will make sure that this is 0. Okay, because what is the second bit here? 0. So if it's a 0, then I will make sure that it moves to the next state. Now remember, my outputs are still 0 here because I have not found out the sequence. I have found out only 50% of the sequence, which is 1 0. Still I'm yet to find another set 1 0, right? So then it moves to the next state, which is S2. Now here the output is 1. Okay, so if it's able to detect this input, which is 1, okay, then I will move it to the next state. I'll move to the next state, and it's going to state 3. And in the last, okay, if it gets 0 as the input, then what happens? Can you see my output here? Yeah, what is happening to the output? It is changing to what?
1, sir.
1. So which means with this straight path, okay, I am able to detect 1 0 1 0. Okay, now let us go to the, now till here any doubt, students? Till this point any doubt?
No, sir.
Okay, fine. Now let us go with the other case. Okay, now we have as I told you, we have 2 cases, which is 1 and 0. So here when it is 1, it is moving to next state. So when it is 0, okay, what is my first bit here? First bit is what?
1.
1. So when it is 0, there's no point in me going to the next state, because it means that I have not detected my input. So what I will do is I will go and sit in the same state till I get 1. So which means 0 means I will be in the same state. Okay. Only if it's 1, it is moving from S0 to S1. So if I get a 1, then it means this bit is done. Getting my point? All of you are understanding what I'm trying to say?
Yes, sir.
Okay, good. Now let us go with the next case. Okay, now here we are in S1. So S1, when it is 0, it's going to the next state. But when it is 1, what will happen? When it is 1, I will be in the same state. Now my question is, can I actually take this one to state S0? If I take it to state S0, what is going to happen? Why am I keeping in the same state?
Sir, if we keep in the same state, we have to traverse the stream of bits only
Correct.
once.
Okay.
If we go back to the initial state, we have to whatever we have discarded, leaving that, we have to start and traverse the whole bits again.
Yeah, so which means it's again going back, right? So I do not want that to happen, because I've already found out 1, right? So when I've already found out 1, there's no point in again going back and searching for 1. Instead, I will only search for 0, isn't it? So what I will do is I will not disturb state S0. S0 is set now. Okay. So I will be in the same state because I've already received 1. So I will look for the next state, which is 0. So till I get to 0, I will be in the same state. I'll be in the same state because 1 is already received. 25% of my work is done, right? So I don't have to go back again and start from 0. Understanding, students? Yes? Okay. So when I'm in this state, what is going to happen is I have a 1, okay? Then I have a 0. So which means a 0 is also detected. And when I have 1, I will be in the same state. Say, for example, if I go to the next state, okay, which means instead of being here, if I go to say S0, then what is going to happen? So in that case, okay, let me just clear everything. Yeah. So instead of staying here, if I go to S0, what kind of pattern will I get? So here I will get 1 with this transition. Okay, with this transition, I'm going to get 1. And here, you know, when it is again 1, okay, it is going to S0. Okay, so which means I am actually looking at one more 1. So is it matching my initial 2 bits here? My initial 2 bits, is it matching? No, right? I should be
No,
looking
sir.
1 0, but here I am actually getting 1 1. So I shouldn't go this path. So which means this path is wrong. So instead, what I should do, I should be in the same state. Since I've already received 1, since this 1 is already received, I will not worry about it. I will now only look for 0. So here I'm getting 0, fine. So once I get 0, move on to the next state. Don't be in the same state. So it is just like jumping from one bit to another bit. Now I got 0, fine. I will now, my target is looking or searching for 1. Understood? So here I got 1. Now see this case. In this case, if it is 0, I cannot be in the same state. Okay? Because I can look for 1 even here. Okay? Even here. Because I'm getting 1 here. Yes or no? So what I have to do? I have to go back to state S0. Okay? See, it is like this. I got 1 0 here. Okay? So I'm happy that I have finished 50% of my detection of stream. But still I have to receive 1 0, but that's not happening, right? I'm getting 0 0 here. So what I will do, I will again go back to my first state. I will again go back to my first state, and I will again check if those bits I am getting here. I am not getting, so I will move forward. And here I am getting, yes, at this point I'm getting, so I will mark it as 1. So similarly, what is going to happen here is, since uh, since at 0, okay, my stream of data is not happening. See, ultimately your target should be only this number. Okay, only this binary number 1 0 1 0. Wherever you get this sequence, just connect the graph there. Okay, so I have 1 0 here. Now with 0, I do not want a 0, but after 1 0, I actually want a 1. Okay, so what I'm doing is I am connecting it from here to here. Okay, so again it will start checking the sequence, right? Now say for example I get 1 from S2 itself. From S2 itself, if I get 1, then what I will do, I will move to my next state. But if I'm getting a 0, then it means I cannot stay in the same loop. I cannot stay in the same loop. I have to go ahead and look for 1, right? Okay, so I move on to my next state when I receive a 1, because my third bit here is 1. So I received a 1. Okay, so I move on to state S3. One more thing you should keep in mind is, once you have received your full pattern, here you have received 1 0 1 0. You have received your pattern, your output becomes 1, and this one should be again connected back to my initial state. So this becomes a complete loop. Okay, this becomes a complete loop. Understood? So it keeps checking states one by one. Right. So now let's go back to state S2. So in S2, if I get a 1, then only I'm moving. Suppose I get a 0, then I'm going back and looking for 1, right? Can I go here? I cannot go here because it is 0, right? So I cannot stay in the same state if it is 0, because I want to look for 1. So I will go in search of 1, right? So after this S2, it will go to S3 if and only if I receive a 1 here itself. So here I've received a 1. So what I will do, I will go to the next state. Right? So if I'm in this state now, okay, and suppose now my next target is what? 0, isn't it? So if I get a 0, good, I'm done with one pattern. If I get a 1, then what I will do is I will go back to 0. Why am I going back to 0? Because what am I looking for in the end? I am looking for only what? 0, isn't it? I want to complete my pattern. Yes or not? Students, are you following?
Yes, sir.
Yes. So in that case, what I will do, I have received a 1 here. Okay. have received a 0 here. Now I have received a 1 here. Now I am in search of only 0. Okay. So here when I get 1, actually I should be getting 0 as my input. But if I have 1 here, so which means after the 75% of searching of bits, it's actually stuck. So which means I'm not able to find out the other bit. So what I will do is I will connect it to somewhere where it has 0. So here I'm getting 0. I cannot connect it here because it's having a 1. I am in search of what? 0. So here I cannot do because it's 1. Here I can do yes because it's a 0. Can I connect it here to S2? Students, can I connect it to S2 from S3? Can I connect it to S2?
No, sir.
No, you cannot, because here you're getting 1, right? I am in search of 0. So what I will do, I will go and I have to connect it to S1. Understood? So in this way, I finish my graph. Ultimately, at the end, you should check if you have seen for 1, 0, okay, 1, 0 case, 0, 1, and 0, 1. So every state, okay, every state S should be having 2 inputs. What happens when it is 0? What happens when it is 1? And ultimately, you can write what is your output. Okay, what is your output? Input by output. Any doubts, students? Have you all understood the concept?
So
Yes.
one doubt I had, like
Yes.
suppose
Please
for
go ahead.
example, in transitioning from S0 to S1, sir, how are we determining the output at 0? Like 1 by 0. How do we know the output is 0, sir?
Output is 0 because I have not still detected the full stream. No? Till I detect the full stream, my output will always be 0. See, here also it's 0, 0, 0, 0. Everywhere it's 0. Only at one place it is 1. Why is it 1? Because once I finish this stream here, okay, just a moment. Yeah. So once I finish the stream here, this stream I finish, okay, then only I will say that I have received an output 1. Until then, it's all 0. Understood?
Yes, sir.
Now here and all, it is still 0 because I have not detected the sequence itself, right? See, here I have detected only 1. So can I say my bit stream is complete? Whatever question that I've asked you to find out 1, 0, 1, 0. See, the question will be like this. With a state diagram, detect the sequence 1, 0, 1, 0. So that is going to be the question. So from here, okay, from this point is all going to be your answer. So only from here to here, okay, in fact, no, in fact, only this is going to be your question. Detect 1, 0, 1, 0 with the help of a Mealy state machine. Okay, so all that I have here, okay, all that I have here is for your explanation. All this is for your explanation. Right? Any other doubts you have, students?
Sir, when S3 goes to S1,
S3 goes to S1, okay.
S1, and we get an output 0. So doesn't it complete? So shouldn't the output also be 1 then?
No. See, because what is happening, no. Because what is happening is it will actually continue with the sequence. Okay, so since here I have 1, 0, okay, 1, so the sequence is not complete, right? I am actually in search of another 0. So what I will do is I am actually connecting to S1. Then see here the graph should be in fact, in this fashion. Yeah. System. Yes, students, can you respond?
No, no, sir.
Yeah. So what I was trying to say, if you have three shops, one with a chocolate, one with groceries, and one with the milk, okay? If you are in need of your chocolates, you wouldn't actually go for the other two shops. So these two shops, you can consider them as state, okay? So if I am getting one here, okay, but I am not interested in one, I am actually interested in zero. So this will go in search of zero, the state which provides zero. So the state which provides zero is S1, right? So it will go to S1. Now, Rohit, your doubt is, sir, since it goes to S1 and then again it will actually give me a zero, will the pattern be complete? No, it will not be complete because it is in state, it has completed state S0 and S1. Now it should complete state S3. Then only my full pattern will be complete. Understood? Understood?
Yes, sir.
It is like a race. Okay. Say you're taking part in a race, in a 100-meter race. Okay. So you have ran about from 0 meter to say 50 meters. Okay. But my destination is somewhere here. Okay, my destination is somewhere here. So since you have ran about 60%, and then you will say, sir, I will actually run another 40% in this direction. Will you give me the price? Is it possible, Rohit?
No, sir.
Not possible, right? So what you have to do instead, instead of moving in this direction, you should actually complete your race and move in the forward direction. So this is what is happening here. Okay, instead of me looking at the pattern, okay, I am actually in state S1 now. Okay, so I should be completing state S2 and state S3. Then only I can say that I have finished my race. I have detected my sequence. I have got my output as 1. Understood? Any doubts here, students? Please ask, because this is a very important concept and we need to discuss. If you have any doubts, I will not proceed until all of you have understood. Can I proceed if you don't have doubts? Any doubts, students? Please, you can ask me, because this is a very important concept. Sachin, Sagar, Rutesh,
And understood, sir.
understood? Okay, fine then. Well and good. If you all have understood, okay. Uh, yes, I have one request from one of your friends to repeat the concept. Fine. Okay. So now what I will do is I will be looking at my question, okay, which is 1010. So initially I will have state S0, okay, and if I get 1, then I will move to S1. Okay. Next, from state 1, I will move to state 2. Okay, state 2. If I receive another, uh, I have received here 1. Okay, I should receive a 0 here. Okay, let me probably use a different color. So here, if it is 1, it goes to state 1, and state 2 or state 1 to state 2 will happen if I receive a 0. What is this receiving 0, receiving 1? If my input is 0, if my input is 1. Okay, so that is what I'm trying to say. Now from S2, okay, from S2, it has to move to another state, which is S3. Okay, so one bit is detected here, the other bit is detected here. Okay, and yeah, S0 to S1 1 bit, S1 to S2 1 bit, S2 to S3 1 bit. Okay, yeah, so 1, 2, 3, 3, and then my final bit. After S3, what is going to happen? Right. So 1, it will go to state 1, 0, it will go to state 2. Next, I'm looking for 1. If I get a 1 here, it will go to state 3. Then if I get a 0 here, okay, if I get a 0 here, from state 3, the loop is going to be complete, and I will actually complete the loop with the help of a graph. So I will connect it here. Now, till this point, what is going to happen is, I have not received my sequence, so my output is still 0. Here also I have not received my sequence, my output is still 0. Output is 0. But when I come here, have I detected my sequence? See, 1, 0, 1, 0. I have detected my sequence, right? So my output becomes what? 1. Till this point, have you all understood?
Yes, sir.
Yes,
Okay.
sir.
Yeah. Now we have to take the other case. I have only considered 1 bit. Now I have to consider the other opposite bit, which I have not considered in this line, of path. Okay. So if it's a 0, okay, here if it's 1, it's moving to S1. That one I agree. Okay. Now if it's a 0, okay, what I have to do is I cannot actually move to the next state, but instead it's better for me to stay in the same state. Okay, because 0 is not needed at all for me. I need 1. So since it's a 0, I will say stay in the same state, and my output is still 0. Now in this case, I have considered 0. So next I have to consider 1. Now here 1 I have already detected, so I will not again go back and detect the same 1. Okay. So instead I will stay back in the same state when I receive a 1, and my output is still 0. Okay. Now here, when I'm moving from state 1 to state 2, happens only if I receive a 0. Okay. So 0 is taken here, 1 is taken here. Now for S2, 1, if I receive a 1, then it's going to S3. But if I receive a 0, what is going to happen? I am actually in search of what? I am in search of which bit now? Can someone tell me which bit I am in search of?
1.
Yes, I am in search of 1. I am in search of the third bit, which is 1. So what I will do is, if it's a 0, okay, if it's a 0, of course my output is going to be 0, but actually I am in search of 1. So where am I getting 1? I am getting 1 at state S0. So I will just connect it to 1. Okay, so it's just like how I gave you an example. You want milk, go to the shop which provides milk. Okay, you want chocolates, go to the shop which provides you chocolates. You cannot go to another shop and ask for something which is not available there, right? So I am not looking for 0 here, but instead I'm looking for 1. So I know that I'm going to get a 1 with shop 0 or state 0. Okay, so I will be connecting my S2 to my S0, right? So now let's consider the other case. So in the third case, okay, in state S3, I have taken 0 here, but now what is pending? 1 is pending, right? So now I am in search of which bit? Last bit, which is 0. Okay, last bit, which is 0. So I cannot look for S2 because it's giving me 1. Okay, but instead what I can do, I can look for state 1 because it's giving me a 0. So what I will do, I will just connect this to my state S1. Any doubts here, students? You able to understand?
Yes, sir.
Okay. Now this is a very important concept. Okay. So any doubts, please feel free to ask me again. Okay. I will try and explain it in another dimension if you have not understood. Yes. Have you all followed it?
Yes, sir.
Students, the others, what about the others, girls? Any doubts? Shalini, have you understood?
Yes, sir.
Okay, fine. So what we will do now is, okay, I hope you have taken down this problem. And have you all taken down this state graph? I told you to take down. Have you all taken down this?
Yes, sir.
Okay. Now try to analyze. Okay. Now try to analyze. Maybe try drawing it again without seeing. Just see the question and try to understand. Okay, how it can be done. Let us take instead of 1, 1 0. Let me change the question to 1 1. Okay, 1 0 1 1. So if I change the question to 1 1, then what is going to happen? What changes I have to make to my answer? So here I have to make it as 1, isn't it? Yes or no?
Yes, sir.
Yeah, output will remain 1 as it is. So here instead of 1, it should be a 0. Okay, and it is looking for the last bit 1.
So it should go to state S0.
You can either go to state S0 or you can either go to state S2. Okay, because S2 is also giving you 1, right? So going S0 will be too backward. Okay, so instead what you can do, you can just connect it to state S2 because only last bit, no? S3 till S2 we have got it right, isn't it? So we have received a 1, we have received a 0, we have received a 1. Okay, so I just need one more 1. So I can connect this to my S2. So no need to go to state S0. That will be too back. That can also be connected, but not needed. Not needed. So the best way to connect is to S2. One more thing, keep in mind, now whatever solution that I am drawing here, okay, just like how one of your friend told that it can be connected to S0, that is also correct, but that is not optimum. Okay, that is not the best result. You will get result, but not the best result. Okay, so it is a good way of connecting it to the to the nearest possible state. Okay, so I'm getting a 1 here, so I will just connect it to state S2. Any doubts here, students? Yeah. Any doubts here?
No, sir.
Yeah. So please take this as a second example, 1011. Okay. So take that as example 2, 1011, and draw the diagram. While drawing the diagram, try to understand how it is transiting from one state to another state and how the values are changing, okay, from 1s to 0, and how the output is changing from 0 to 1 only here, and why am I connecting back only to S2? Why is it getting connected to S1? Okay, so all that you should check. Now here you can see that, I have written the streams that it can follow during the path. Okay, so during the path, what all streams that it can come across. Okay, So it can come across 1001, okay, 10, okay, 01, or sometimes it can be 100. I don't care. Okay, so step by step it's going to check. Step by step it's going to check, and ultimately once it detects a sequence here, okay, once a sequence is detected, then immediately my output is going to turn 1. It means that yes, I have received your pattern. Whatever pattern you have given me, I have received. This is as good as training your AI, okay, training your artificial intelligence in finding out some values, okay. So this kind of state machines can be employed even in your facial recognition, okay. How does it work? Your fingerprint, why does a phone respond only to your fingerprint, not your friend's fingerprint? How does it work? Because you've already given an a model, you have trained your cell phone, isn't it, by giving repeated fingerprints in different angles. Yes or no? Yes, students, can you respond?
Yes, sir.
Yes, sir.
Yeah. So since you have given your sample, okay, in the form of fingerprint in different angles, so it has understood, okay, so if I get a pattern in this way, then only I'm going to unlock my phone. If not, then no, I'm not going to unlock. So I have trained the system in such a way that, I should be able to detect only this sequence. Okay. So if it's not detecting that sequence, then it's not going to turn on, or it's not going to turn 1. So which means your cell phone is also not going to get unlocked. So many applications, okay, with respect to your Melee state machine. It could be in with your facial recognition. It could be with your fingerprint recognition. Okay, it can be training your systems. It can be your AI systems where you train the model. Okay, and then you feed data to the system, and it understands. Okay, if I get only these kind of data, then only I'm going to process it. Okay, fine then. So I hope all of you have understood today's class. Okay, today's lecture, wherein we have discussed about the bit pattern. So we will try and understand few more concepts in the upcoming classes.